Hey everyone, in this video we'll learn all about composite functions. So let's write a function down. Let's say we had m of t equals 50t, just a regular function. And now let's talk about what this function means. So m of t is the amount of miles driven. So the amount of miles driven after t hours. So after t hours, t is our input, we have driven m of t miles. M of t is the output. So for a quick example, let's say we had m of 3. Let's make that 3 a different color. So m of 3 would be 50 times 3. So 50 times 3. And what's 50 times 3? That is 150. So what this 150 means is after 3 hours, we have driven 150 miles. So 3 is our input, and 150 miles is our output. So we've driven 150 miles after 3 hours. Great, so now let's write down another function. Let's say we had c of m equals 20 plus 1.5 m. And now what this function is supposed to represent, c of m, the output, is the cost of a taxi. So this is the cost of a taxi after it has driven m miles. So now in this function, m is our input, m miles is our input, and c of m is our output. So after m miles we have driven, so after m miles, our taxi will cost us c of m, let's say dollars. So let's write down an example. Let's say we had c of 10. So 10 being miles, 10 miles. So c of 10 would be 20 plus 1.5 times 10. Okay, so let's evaluate this. What's 1.5 times 10? That's 15. And 15 plus 20 is 35. So 35 is what this equals to. So c of 10 is 35. So what this means is our taxi will cost us $35 if we drive for 10 miles. So if the taxi's driven 10 miles, which is our input, it'll cost us $35, which is our output. Great, so now let's say we wanted to solve a new problem. Let's say we wanted to figure out, so we know these two functions, m of t is 50t, and c of m is 20 plus 1.5m, and we know what they both mean, what they represent. And to solve now this new problem that we want to solve, let's say we wanted to know the cost of a taxi. So the cost of a taxi after 4 hours. So if we ride the taxi for 4 hours, how much will it cost us? Well, we can't really use this cost formula right here because this cost formula is c of m. So c of m. And we don't know m because we don't have m, we don't have miles driven. We have hours passed, we have 4 hours. So we need t to represent the hours. But we have this other formula, m of t. So what we're going to do is we are going to compose these two formulas, or these two functions. So we are going to write c of m of t. So we've composed these two formulas, or these two functions. We've composed c of m with m of t, and we've put m of t inside c of m. So this is a composite function that we've created, c of m of t. A composite function is essentially a function inside of a function. So we've created this new composite function, and now what we can do to solve this problem, the cost of a taxi after 4 hours, we can go ahead and look for C of M of 4. So C of M of 4. Okay, so C of M of 4, how do we evaluate this function? Well, what we're going to do is first evaluate M of 4. What is M of 4? Well, we know M of t. We know that M of t equals 50t. M of t is 50t, so let's write that down again. M of t is 50t. So what's M of 4? M of 4 is 50 times 4. So M of 4 is 50 times 4, which is 200. M of 4 is 200. Great. So now we know that M of 4 is 200. So let's move this to the side. So we know that M of 4 is 200. So we can replace the M of 4 with 200. So we could write C of 200. And now we can evaluate C of 200 because we have the C of M formula right here. C of M equals 20 plus 1.5M. So let's write that function down again. C of M equals, and that is 20 plus 1.5M. So let me actually just move this a little bit over here, and it is 20 plus 1.5M. So 20 plus 1.5M. Just divide that. Okay, so to find C of 200, that is 20 plus 1.5 times 200. So to evaluate this, what's 1.5 times 200? That is 300. So plus 300, and then 20. And 300 plus 20 is 320. And that is the answer. So the answer to our original problem, how much does it cost our taxi to ride it for 4 hours? And the answer is $320. And we've answered that question using this composite function right here, C of M of t. And we found C of M of 4 equals 320, our final answer. $320. Perfect. Now, let's say we wanted to find C of M of t. We wanted to find a formula for it algebraically. So C of M of t. Let me go ahead and write that down again, down here. C of M of t. And we know what, let me go ahead and just move this up a little bit so we have some space. Let's move this down. We know what C of M is. C of M, up here, our original function, C of M is 20 plus 1.5M. So C of M equals 20 plus 1.5M. Let me actually make the M a different color, just so that it pops out. So let's make the M blue. Okay, so now, how do we find C of M of t? Well, we know C of M is 20 plus 1.5M. So C of M of t, we're simply going to substitute M for M of t. So this would be 20 plus 1.5 times M of t. And what is M of t? Well, M of t is up here. M of t is 50t. So we know M of t equals 50t. So this means that C of M of t, so let's just write an equals. So C of M of t equals 20 plus 1.5 times 50t. Because we know that M of t equals 50t. And let's keep evaluating this. So what is 1.5 times 50t? That is 75t. And then we will go ahead and write down the 20 plus. So there we go. Our composite function, c of m of t, we have created a new formula for it. It is 20 plus 75t. And now we can go ahead and test it. So our original problem we had up here, c of m of 4, we know is 320 right here. So let's find c of m of 4 using the new formula we've created. So c of m of 4. So c of m of 4, let me just write that again. C of m of 4 equals 20 plus 75 times 4. And to evaluate this, 75 times 4 is 300, and 300 plus 20, so 20 plus 300, that is 320. So 320, and that is the same answer we got up here, 320. So that's how we know that this new formula for our composite function works. C of m of t equals 20 plus 75t. Now, it's very important to mention that it matters which order you compose these two functions in. So we've composed the functions this way, c of m of t. So this is our composite function right here, c of m of t. This is different from m of c of t, or m of c of m, rather, because we know what c of m is. M of c of m, let's go ahead and try to find this. We know what m of t is. We go back up to our original one right here. M of t is 50t. So we know m of t is 50t. So what's m of c of m? That is 50 times c of m. But now what is c of m? C of m, as we saw up here, is 20 plus 1.5m. So we can go ahead and rewrite this as 50 times 20 plus 1.5m. So 20 plus 1.5m, there we go. And we can go ahead and just simplify this. We have a 50 outside the parentheses, so we're going to distribute it. So what's 50 times 20? That is 1,000. And what's 50 times 1.5m? That is 75m. So this function right here, m of c of m, is 1,000 plus 75m. This is completely different than c of m of t. So it matters in which order you compose these two functions. C of m of t is completely different than m of c of m. And you could see their formulas are completely different. 1,000 plus 75m and 20 plus 75m. All right, so now let's go through another example together. Let's say we had a table right here. So we had x representing all our inputs. We had f of x, a function f of x, and then another function g of x. And let's say on our table, for our x values, our inputs, we had 1, 2, 3, and 4. And for f of x, f of 1 is going to be 5, f of 2 is 7, f of 3 is 9, and f of 4 is 12. Now for this function g of x, g of 1, so again, x is our inputs, g of 1 is 1, g of 2 is 9, g of 3 is 3, and g of 4 is 17. And let's say we wanted to compose f and g, these two functions, and we wanted to go ahead and find f of g of 1. So how do we find that without formulas? We're just using these tables. How do we find f of g of 1? Well, what we're going to do, the first thing we're going to do is find g of 1. So what is g of 1? G of 1 right here equals, well, we know at x equals 1 right here, g of 1 is going to be 1, according to this table. So g of 1 is 1, and f of g of 1, we know that g of 1 is 1, so this is just f of 1. Okay, now, what is f of 1? Well, we know f of 1, according to this table, is 5. So f of 1 is 5. So we know f of g of 1 equals 5. And that is how we find it by composing these functions. So I hope this video helps you to understand composite functions more. And if you have any questions at all, please leave them down in the comments below. And thank you for watching.